Welcome to part 2 of Competency 17. In this video, we will work with procedures and concepts. Number 1, teaching mathematics through problem solving. Okay, we need to finish the sentence. Let's look at A. Should be used after students have learned the basic concepts. I don't like that inclusion because it is not uh, student student centered or self discovery because of the word problem solving. They're talking about problem solving. That you got to think about what that means and what the purpose of that is. So A would not be an option. Let's look at B. Is too time consuming to work in a real classroom setting. That is negative. Anything like that, anything negative, don't even consider it. Just mark it out. Let's look at C. Encourages students to think and act like mathematicians. Although you may think that's corny, that's the best answer so far. It makes sense. Thinking for themselves and solving things in different ways, blah, blah, blah. Act like mathematicians may seem a little corny to the general public, but for educators, that's going to be in our rhetoric. So that's a good option. Let's look at D. Is too difficult for most students and should be used only in honors classrooms. That is even worse than B. It's worse than option B. So that is going to verify C for us. I like C. It sounds great. It sounds like a great textbook question. Or statement. Teaching mathematics through problem solving encourages students to think and act like mathematicians. It's a good sentence. Okay, let's go to number 2. A teacher starts his class by showing students how to factor an algebraic expression using algebra tiles, then tells the students to use the tiles to factor several expressions found in their textbook. The teacher notices that the students are using the pen and paper method he showed them the day before to find the answers and then group the tiles accordingly. What should he do? I see what happened here. What you should do is introduce the tiles first, then from the tile, this is what I would do. I would introduce the tiles, have some activities with that. And then the next day, I would move from the tiles to the box method. Okay, if you're not familiar with that, you can look that up. There is a factoring box method. Just Google it. Okay, I would go from tiles to the box method. Then I would go to something like the foil method. I would show them other ways. And then when it came down to other activities in the future for the ones that were struggling, they can go to either method they want. If they feel comfortable, then they can just move on with foil, or there's another traditional method. So that would be my process. But let's see what our ABCD says. A, nothing. The students can get the okay. The students can get the correct answer. That is neutral. There has to be an action, and it has to be a positive action from the educator. Okay, so that is neutral. So mark it out. Anything that sounds like that, always you just don't consider it. Let's look at B. Rearrange the unit plan so in the future, the manipulatives are used before the algebraic strategies in a discovery setting. Now that I like, and that's kind of what I said. So I'm going to circle that for now. I like that one. Let's look at C. Forget about using manipulatives in the next class period. They're a waste of time. That is negative. They're not a waste of time if you know how to put them in an activity. Yes, you may not have to use them a lot, but they do help mental processes, and they're tactile. So you may have learners in the room that need that touch. So I don't like that at all. So that's just seems very negative. Okay, let's look at D. Stop the class and repeat the example that he showed them at the start of the class and insist the students use the tiles to factor the expressions. That is negative also because of the word insist. The only time you'd stop the class is if they had a huge misunderstanding. Obviously, the students aren't misunderstanding the assignment, and they probably are gaining something from going back and forth from the tiles to the paper. They're working it out, then they put it in the tiles. I bet you 10 to 1 it isn't what he intended, but some students might notice a mistake in their actual pen and paper work when they go to the tiles. So it may seem like it's the best way is to insist it. I wouldn't insist. I would just let it go with the flow and do what B stated. Rearrange so you can do better next time. And if you had a walkthrough and it looked like to your evaluator that things weren't going exactly the way planned, then you would say, well, in future, this is what I will do. Although I do see the students actually engaging and being successful. So you haven't lost anything. Okay. All right. So B would be the best answer there. Let's look at number 3. Which of the following provides hands on activities that would be useful when expanding students' learning from concrete to abstract? Okay, this is all our what we've done in our education classes. All right. Well, this would apply to anything, not necessarily mathematics. Discussions? No. Discussions, especially if you're thinking about math, no, that isn't concrete. It has nothing to do with it. That's more of concluding other things. Yes, discussions are good, but not for this. Concrete to abstract projects, I disagree with that because projects would be after they understand a abstract. Projects are at the end of understanding, they're not for that discovery. Concrete to abstract implies discovery and, moving on. It's a continuation. A project I would do at the end, that would be like a final grading. Okay, not for that kind of basic discovery. Manipulatives, absolutely. Working in groups, no, that's just a strategy that you might use with the manipulatives and many other things. But it doesn't apply to this particular educational idea. So no. So I would stick with C, manipulatives. Okay, let's go to number 4. Number 4. Ms. Fisher gives each group of 4 students a bag of candies containing 6 sorted colors. She asks the students to make a circle graph using the candies as the circumference of the circle in such a way that the circle obtained would show the color sections for each color of candy. Then it could be used to draw a circle graph without actually counting the candies. What might be the most appropriate reason designing Miss Fisher's designing this task for her students to do? Okay, that was a big mouthful, but if you want to know what that circle looked like, you can rewind the video. That was the image that was it in the intro for this video. But let's read why would you do that? You have a graph with colors. And when you have the students make the circle, putting all the colors right next to each other in sections. That would make a pie graph, and then they'd have to count the total. It'd give them part out of total in each of the sections. So visualize that. And now that we visualized it, let's see what A says. Students would be able to visually see how the data reflects the fractional sections of the circle. That's what I just described. That makes sense. That would be a nice visual. And I like the way they talked about a type of learner rather. So I'm going to underline A for now. Say, I think I like it. But let's keep going. B, students always like food, especially candy, to work with a manipulative. No, that just doesn't have an educational quality. It doesn't give a good rationale. Okay, C. Students would be able to calculate the percentage of each color of candy in the bag. Okay, that would just be a probability. The what with that description, that would just be a probability activity, part over total. That wouldn't give that nice circle with the sections and the colors. So I disagree with this. It just doesn't give a good explanation of why to do it. Okay, let's see D. Students would be able to determine the number of candies needed to make the circle's radius and then calculate the area of the circle. That is not at all what's being described there. So I disagree with that because it said circumference particularly. So that counts out D. That just doesn't make sense. So looks like A is going to be our best answer. All right, let's look at number 5. Which of the following types of lessons would be most beneficial for a student who is a visual learner? Okay, A, listening to the teacher lecture. Okay, right off it says listening. That has nothing to do with visual. Okay, and then B says reading an activity sheet. That doesn't make sense. Let's see C. It says watching a video of a ball being tossed upward while watching an animation of a graph that relates to the distance of the ball traveling in time. Okay, yeah, sure. They're watching something that relates to their topic. I'll buy that. Let's look at D. Using pattern blocks to to explore fractional relationships, that has to do with touch. So that's for those students, those kinesthetic students, those students who need to touch things. So I would disagree with that. Okay. If you didn't notice, this entire video, we did not use the calculator. And I considered leaving this part out, but I think it's useful, and these kind of questions will come up. I just needed you to see when not to choose, to look at certain questions rather that are neutral. Don't choose anything that's neutral. Don't select any options that are mildly negative, anyway negative at all. Choose answers that are more student centered and understand the vocabulary and what it connects to as far as the types of learners. Okay. All right. That would be the last question in this video. I want to thank you guys so much for liking, sharing, and subscribing. It's been very helpful. And we're going to keep making things, rather videos and posting things. And I hope you keep watching. Happy testing, everyone.